this is a short introduction about myself. That's why I asked my colleague that she doesn't need to introduce me. Okay, so first of all, I'm very happy to present here at this conference. Unfortunately, I thought that the only reason why I applied was the Oktoberfest name, so I thought that I'm going to be drunk at this time of the day, but it's not the case. That's funny. But anyway, yeah, I hope to share with you some interesting stuff. I'm coming from software development world mostly, and I moved into data world and management recently. But with a focus on productionizing machine learning. So that's all about myself. Maybe I'm going to ask you a question because in order to know each other. So how many of you are data scientists? I suppose most of you are data scientists here in the room, yeah? Can you raise your hand? Data scientists, yeah. Okay, anybody with software engineering kind of background, yeah? And DevOps? Are there any DevOps here? Okay, that's fine. Hopefully you're gonna help me moving forward. So what I'm trying to tell you. So first thing is the one I think maybe not very particularly deep user story, but good example of what I try to present. That's where I start, what I would like to start from. Then I would like to share with you my experience with WASM. And before I would like to, discuss a little bit why it's all about, why it's WASM and things like that. And I'm going to share with you, one. For those of you who like to have some meat at the conference and like to look at something that actually it works, and yeah, it's additional reason for me to be excited is that I'm going to, and a risk and failure is that I'm going to actually do something live here. I'm going to run an experiment that I prepared. So be patient. Those two last points are actually the most important one, in my opinion, and most interesting ones. This last one is about one magical solution that I found after this whole suffering with trying to build WASM modules and try to run them in production. Okay, so let's start with the story. The story is about the city of York. You are an engineer, a water engineer in the city of York. York, Canada. My company is a Vancouver-based company, so it's my customers' world. So you collect the sensor data from the water level data in, let's say, in particular point of the city. And what you would like to do, you'd like to build a model that's going to fix the quality of the data, improve the quality of the data, because the city engineer is maybe willing to do something more with the data and willing to build advanced engineering model. So, and unlikely he want to plan infrastructure, but water infrastructure, but the data the data quality is low because of a bunch of different reasons. It might be sensor malfunctioning, yeah. It might be battery goes down, and for some period of time, its data the quality is low. So you want to solve this thing. You are a data scientist. So for those of you who are data scientists, how would you approach this kind of problem? What would you do in terms of tooling? What would you do in the first place? What is your approach? What would you do? You would use some kind of environment, yeah? Probably Jupyter Notebook or something like that, yeah? Common, very common. So yeah, and yeah, that's the thing. So you would, let's assume that you found this magical outlier detection formula, and it works for this particular site, and you have your notebook model. And then time series is somehow very specific kind of modeling that it's different. It's not that particular, but it's different than, for instance, deep learning, when you fit one model and you try and you just get predictions and forecasts. Actually, what happens is once you realize that there's not only one side where you would like to get a forecast, but there is plenty of different locations all around the city, you end up with a scaling problem. So you have thousands of models, you need to instantiate them, and ideally, somebody wants to have updated forecasts every real time. So every 5 minutes means real time in our world. Okay, so it's already complicated. It takes resources, and it takes it's computationally expensive. Yeah. So for DevOps, questions for DevOps here in the room. So how would you solve this problem when you have to ship a lot of different models, maybe not necessarily in Python, but using in different programming languages, thousands of them? What would you use? What would you normally do to deploy things to production nowadays? Technology that comes from software world is containers. Yeah. Sorry, you can't read in my mind. So yeah, and that's what we did. We use Docker containers. That's more or less our solution. I don't want to go deeply into. It's just to show you a concept how we solve this production ready ML problem. Yeah, how we scale it. We scale it with Kubernetes. We scale it with message queue. We scale it with Dockers. But at some point, and sometimes it works when you actually not fit your model too frequently. But it has drawbacks. So if you go into scale, you have numbers of Dockers in production, and you need to instantiate them, and then stop them, and relaunching them constantly every 5 minutes. It's a problem. Then you have each Docker process have process overhead, and it's performance far from native kind of performance. So if you really want to go into scale, it makes things difficult. Yeah. So that's where the WASM idea comes to my mind. So WASM, short introduction to WASM for those of you who don't know what it is. It's the concept. The name is Web Assembly Module. It's a way to deploy code modules from server programming languages into a browser. Yeah, that was the original concept. So you might be able to run in your browser. Your browser becomes your OS basically. So you're able to run Rust in browser. Yeah, and browsers, okay, but all of a sudden, people from WASM community they saw an opportunity to move WASM outside of browser. Yeah, to make it, because it's so super powerful. There is a huge opportunity in having a way to run modules of different programming languages, different libraries at server side without all those drawbacks of Docker, things like that. I was so excited about this idea in the beginning when I originally thought about it, that I even thought that maybe at some point WASM is going to be replacement for Dockers, but I was wrong, and maybe I'm going to talk about it. Actually, it's going into different direction. The Docker community adapts nowadays WASM, and there is partnership rather than else. Now, and also for Kubernetes, I don't know if it's already there, but I've read that in Kubernetes they work on WASM-enabled containers. I don't know if it's in beta mode or what, but it looks like WASM going to be somehow injected into the current tools. Okay, and I'm going to share with you in a few sentences. I don't know if I have that much time. My journey with trying to prepare a live experiment with WASM for this presentation. So first, I know that data science word is Python word, yeah? My team, we are mostly Pythonians. The dev side is Scala and functional languages, but most of data scientists, they use or R or Python. So I said, okay, WASM for data science, but first you need to have Python. And so I thought that, I knew that it's immature, but I saw very interesting project from VMware on GitHub. They were able to build WebAssembly from Python environment. So, and I saw how it works. So you are capable to run Python in WASM and, you know, statically add your libraries and things like that. So I said, okay, that's what I'm looking for. I'm going to just take the forecasting model in Python and try to run it this way. No, it doesn't work. It didn't work for me. It's for a bunch of different reasons. One of the reasons was that adding custom libraries to this solution was painful. Then I said, okay, so let's go with Rust. Rust is somehow WASM-ready language. So in perfect example that I wanted to share with you, I wanted to use Parquet served from S3 storage, because it's more standard and it's better and more exciting, more interesting than, you know, trying to process static files. So next problem is sockets. Sockets are still not there in WASM, so you won't be able to do even simple things that you are used to do in your, you know, computer program. So you usually would like to use HTTP communication, something like that, yeah, for instance, exchange the data. So I end up trying to embedding WASM time in Rust. So making, you know, preparing an example of how you can efficiently run a number of WASM modules in Rust. Still, you have to deal with memory allocation. I don't know how many software engineers maybe do you have some experience in C and this, you know, assembler era where you have to allocate memory on yourself. So it's some kind of similar experience with Rust modules, WASM modules in Rust. And yeah, and I end up in something that I call dependency hell, and that was my experience with WASM in Rust. And yeah, and I thought that maybe what I'm going to share with you will be just lessons learned of how wrong I was. But I'm just, finally I did it. So I prepared something that makes sense. So in order to show you that, I'm going to show you, for simplicity's sake, let's say our forecasting model is something that I call daily pattern, yeah? So here you have this module, WASM module, that you process file, you see buffer, it's not string, it's not file, it's like Arrow. And Arrow, for those of you who don't know, is a way to store the data used by Polar's library. I recommend you know, digging deeper into Polars if you don't know. It's a super powerful tool. It's based on Arrow. That's why I introduced Arrow here concept. It's super powerful, super fast, super efficient. And the model here may sound silly. It's daily pattern. We use it frequently as a base model for our deployments. to compare with. And actually, it's funny that it's very difficult to beat this model, because if you have time series data here, it's daily. You see that it's seasonal. There is the daily pattern, and you just get it 288 values, which is averaged by 5 minutes. And this is something that you use for prediction, for a base model prediction. And yeah, it's quite powerful. I don't want to go into details. I use it only for simplicity's sake. And actually, I'm a really bad coder, so I wanted to use something simple, yeah, in Rust, and to make it happen. Basically, that was my goal. And then, what actually worked for me is, I found this philosopher's stone, which is something called Dino. And in Dino does everything for myself that I wanted originally to build manually. And I'm going to share with you the outcome, if I have still some time. Okay. So first of all, I can't. I can't tell everything that I wanted to, but actually the thing that I recommend if you want to build WASM is something called WASM Pack, and it's here. Excuse me, WASM Pack. It's like you just download the template and you just build it like this, and it works actually. It builds and it works. The problem that I had in the beginning was that I didn't want to really run anything in a browser, and WASM Pack builds for you browser-ready kind of package, yeah, with a bunch of JavaScript here and things, JavaScript code here and things like that. So this is your package, and I created something called Runner, and with Dino I run my WASM modules, and I did blah 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 blah. Okay, sorry for that. NumPy. Okay, so this one is the Rust module. This number 150 means is a parameter. I'm going. Comment not found, Dino. Ah, well. Okay, I'm in different terminal. Oh yeah, that's right. Thank you for that. Yeah, it's. I haven't exported the environmental path. Okay, so this one is the Rust version, and it calculates the forecast. So I've used 3 different CSV files, and I iterate them in order to get, the volume of data to process, and looks how it works. And and it's parameterized to make it, make it fast. Okay, maybe I don't have time to run this that much. I'm going to run it only with 3 parameters, and I'm going to compare it with pandas. The same thing in pandas. It's like 138 megs in 1 second. And then let's run NumPy version. Believe me or not, it's the same code written in pandas, not in polars. And I was able to run actually Python with things called pyodide, which makes Python available in browser. It's a WASM behind the scenes. So look how it works, and this is the outcome that I wanted to.
So you tried to compare them with pandas too?
Yeah. So
that's pandas.
This is pandas.
I know,
Yeah.
but if you do pandas too, I'm sure there's difference.
I don't know. I think
pandas too has quite an optical.
you think so?
No,
Maybe.
I know so.
Yeah, but I think that there is also an overhead of running in pyodide. That's the problem. Maybe it's not a fair comparison. You're right. Okay, but I think it makes a little bit of sense for somebody. Okay, it maybe. So yeah, again, good point. Python in WASM is still under development. At some point, I think that Pio died. It wasn't apples to apples comparison, that's for sure, because it's not pure WASM. It's something created for Python. Yeah, sockets is the no-go, and yeah, I haven't talked about parallel tasks here, because in Dino I found a way to run tasks in sequence, and if I had the time to share my code with you, you would see that I had only one task, and I was putting everything into one task. So yeah, and hopefully in a warmer environment on May next year, we're gonna meet together with the same audience here. Yeah, that's thank you for having me, and hope it makes sense to someone. That's what I've shared. There's no time for question. I consumed everything. So again, thank you very much. Yeah.